This is a review of balancing and working with redox reactions. In a redox reaction, there are substances which get reduced. We call them the oxidizing agent. They actually gain the electrons and take on a more negative oxidation state. The reducing agent, on the other hand, gets oxidized, it loses electrons, and takes on a more positive oxidation state. In the following equation, see if you can identify the oxidizing agent, the reducing agent, the substance being oxidized, and the substance being reduced. You may want to pause the podcast and make those identifications. Now we take redox reactions and we break them down into half reactions. One half reaction produces the electrons, that's the oxidation half. The other half actually requires electrons, that's called the reduction half. So take the following two reactions and see if you can write the half reactions. So you may want to pause the podcast here and take a shot at that. Now in balancing redox reactions, the key is the number of electrons produced must be the same as the number of electrons actually reacted. So for reactions in acidic solution, it's really kind of an 8-step procedure. So number one, you write the separate half reactions. We've already kind of practiced that. Step number two, for each half reaction, balance all the reactants except for the H and O. So if there's a Cl2 on one side and a Cl- on the other side, you need to balance those kinds of elements. Step number three, we want to balance oxygen using water. So you're going to add water to either side in order to balance the number of oxygens. Now when you add the water, you're actually adding H's. So in order to balance the H's, we must use H plus to do that. So we use the H plus in order to balance the hydrogen. Step number 5 then is balancing the charge. So you need to add up the charge of everything on the left side, everything on the right side, and then put in the correct number of electrons on the correct side so that the charges on the two sides of the equation are equal to each other. Step number 6 then is to make the electrons equal. So if you have 2 electrons, for example, being lost in the first half reaction, 3 electrons being gained in the second, you would multiply the top reaction by 3 to make it 6 electrons and the bottom reaction by 2 to make it 6 electrons. So the key is getting the electrons equal. Step number 7, you're going to add the two equations together and you're going to cancel out things that are identical. This is where the electrons actually drop out. And if you have water on one side and you have waters on the other side, you can actually simplify those waters. You can do the same thing with H+. You just need the values to be positive. So however you simplify the waters in the H+, make sure that they're positive. And then step number 8, you need to check that the charges are balanced. So you add up all the charges on the left side, all the charges on the right side, and make sure that they're equal. And then, like always, make sure that the elements on both sides are actually equal to each other. So now to practice this, all of the following equations occur in aqueous solution. So if you could pause this video temporarily and balance the 4 reactions that you see there. And then here's a slightly more difficult one. So take this equation and give that equation an attempt at balancing. So you may want to pause here as well. Now, what happens when we're in basic solution? Well, in basic solution, you want to do everything just as you did in the acidic solution, but you want to add one more step. The additional step is to add enough OH- to both sides to neutralize the H+. So if there's 4 H+, let's say on the left side, you're going to add 4 OHs to that side and 4 OHs to the other side. The H+ and the OH on the one side will combine to form water, and then the OH on the other side by itself will just stay as OH-. So here are 3 that you can actually attempt to balance in basic solution. So you may want to try these 3 reactions.